Hey guys, how's everyone doing? Hope you had a great 3-day weekend. I know I sure did. We are continuing with organic. We left off on Thursday with breaking down the name to find out how many carbons or what type of hydrocarbon it is. Today we're going to focus on that a little bit more, but now we're actually going to look at the organic structure. Now, like we said on Thursday, your structure could either be or structural or molecular. We're really going today to focus on the skeletal diagrams and being able to name from them. Usually, if we were in the classroom, we would be drawing and naming and drawing and naming and drawing and naming. But because we're doing remote learning, it's a little hard to do the drawing part of this aspect. So we're going to focus mostly on naming. So really simple when it comes to naming. As you know, you look at the prefix, you look at the suffix to find out how many carbons it has, what type of hydrocarbon it is. Today we're focusing on the same thing, but we're going to look at the actual structure to help us come up with the name. So here we go. So this is our do now, and I only took a couple of problems because I just wanted to do a couple of them with you. I want us to be able to let me get it harder. I want us to be able to determine how many carbons, what the series is, the homologous series, right? I just like to call it hydrocarbon, but it is actually known as the homologous series. What type of homologous series is it? That means it's an alkane, alkene, alkyne. And then, based on the formula, what is our molecular formula? Now, the formula is given to you on table Q. For the formula is given to you on table Q, so you only have to look at that and plug in the information to solve. Really, it is a first level algebra, right? So I'm pulling out my reference table. Give me 1 second, and then we're going to use that to figure out the. We're going to use that to figure out the number of carbons, the series, and the formula. So and you also have a quiz on this, so it's good to get a little practice before your quiz. So like I said, we're going to start with methane. So the prefix over here is meth. I'm going to look at table P, and I'm going to notice that meth means 1. All right. Now, because it ends in A and E, I'm going to look at table Q to see which one of my series of my hydrocarbons ends in an A and E, and that will be alkanes, right? All right. Now that I know it's an alkane, I need to come up with my formula, which is going to give me my molecular formula. So the formula for alkanes is CnH2n plus 2. So same as the top. CnH2n plus 2. All right. Now, N is always going to be the number of carbons. So I only have one number of carbons. So C1. And then H is going to be 2 times 1 plus 2, which 2 times 1 is 2, plus 2 is going to give us 4. So my molecular formula is CH4. And for my very strict people, we can say C1H4. All right, let's go to butene. Butene is a little different. Bute. I'm going to look at table P once again. Bute is 4. 4. That is what bute, the prefix bute stands for. I use table P to help me figure that one out. Then I'm going to look at table Q to see which one of this homologous series it is. Because it ends in an ENE, it is an alkene. It's an alkene. So that means, and if I look at the structural diagram on table on table, what am I trying to say? When I look at the structural diagram on table Q, I know that an alkene has a double bond, meaning I'm sharing 4 electrons between my carbons. Now, that formula is CnH2n. So CnH2n. Now remember, my number of carbons is my N value. If you forget, on the bottom of table Q, it tells you what your N is. So your N is your number of carbons. And I had 4 carbons here. So C4, or let's figure out my H, how many hydrogens I have. H, well, 2 times 4, which is my N again, gives us 8. So C4H8 is my molecular formula. And that's it. Alright, I'm going to leave the rest to you. Honestly, just use your table P and Q to help you out with the do now. Really simple. So let's move on. So when we left on Thursday, we were focusing on the chain part, right? Use the prefix, all of that. Use the prefix, use the suffix. Really simple to name. So I'm not gonna bother you with that. You probably will have maybe a little pop quiz that's gonna ask you to produce the names of hydrocarbons that have like 6 hydrogens, and if it's an alkane, give me the name. We'll try that later on this week. However, today I want to focus on not the chain. We're still focusing on a chain, but we're no longer focusing on a straight chain. We're focusing on branch chains, right? And branch chains just basically means that the carbons are no longer going in the same direction. There is another carbon that's branching off from the main line. The main line is known as the parent chain. The parent chain is the longest amount of carbons you have on in a direction, right? Anything that branches off, that stems off of it, that is that's your branch. Now, before we really go into branch a little bit further, I still want us to practice a little bit on the chain because I don't want you to get a little bit confused as we go on towards the end. So let's go on to the next side. So we're going to practice how to do the chain, and this practice is going to help us with the branch later on. So for working with the chain, the directions are here, but I'm still going to just do as I do a problem. Now, alkanes are the easiest ones. How do I know this? So like I said, alkanes are the easiest ones. How do I know that this is an alkane? Well, look at it. All over, we have single bonds. All over, we have single bonds. So that means that we're dealing with an alkane. If you ever get confused, look at table Q, because the structural formula should look like what you have on your paper. That structural formula example should look like what you have on your paper. So, or on your screens, in this case. So, we know this is an alkane because we only have single bonds. Great. Now let's figure out how to name it. So, like I said, because we're dealing with alkanes and we're dealing with single bonds, there's no need to really number the carbons. So we're just going to count to see how many carbons we have. So we have 1, 2, 3, 4, 5. We have 5 carbons. Let me just get, we have 5 carbons. So we have 5 carbons. My hydrogens are not important. Why my hydrogens not important? Because when it comes to hydrocarbons, we name them based on the carbons, not the hydrogens. We are naming them based on the carbons, not the hydrogens. So if I look at table P, I have 5 carbons, and 5 carbons, my prefix is pent. And now, because I look and I only see single bonds, single bonds, single bonds, I know this is an alkane, so that means my ending is going to be the same as any alkane, or even the name alkane. My suffix is going to be A-N-E. So my full name is pentane. Pentane is also a type of gas. And there we go. That's how you name an alkane. Very, very simple. Not even going to question it. Let's go on to alkene. So alkenes, now you see this is a little bit different. because now we see the double bond right here and right here. These are two separate examples, right? So we see the double bond right there. So let's go ahead and still count how many carbons we have. We have 1, 2, 3, 4. So we have 4 carbons. Now, my prefix for 4 carbons is bute. Bute, not but. You guys always like to say it's but. No, it's bute, right? So we have bute, right? But now we see that it has this double bond. Now this is where it's very important in the name. Yes, we see it has a double bond, but where is this double bond? So let's first deal with the double bond. So because we know it's a double bond, it's gonna end in the same thing that alkene ends in, which is E and E. So we have butene. All right, that's my ending, that's my suffix. So we have butene. Now, if you told me this, I would be like, okay, but we want to be a little bit more specific in our name. And for us to be specific in our name, we need to know, where did you see this double bond? Where did you see it? What carbon was it located on? So, how do we determine what carbon is located on? We're going to give the carbon a number. And that number is going to tell us what the carbon is located on. So, if you look over here, I'm going to start counting from the side that is closest to the double bond. So I'm going to start counting. I'm not going to start counting from this end. I'm going to start counting from the side that's closest to the double bond, right? So I'm going to start counting on this end, and this is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. This is going to come in real handy in a few moments, right? So our double bond is located on carbon 1 and carbon 2, but we're going to go with the less number first, so it's going to be located on carbon 1. How do I put that in the name? I'm going to say 1, a dash line, butene. That 1 tells me where that double bond is. All right, let's try it over here again. So once again, let's find out how many carbons we have. 1, 2, 3, 4. All right, so we're still dealing with the prefix. We have 4 carbons, right? Sorry, I put that out a little. 4 carbons, that means we're still dealing with bute. And then once again, we have a double bond. That means we're ending in a E and E. Great. Now, I need to know where this double bond is. Now, see how it's located in the middle? Meaning, it doesn't matter if I start over here as 1 or I start over there as 1. I'm still going to get in the middle. So I'm going to start from my left. So we're going to have 1, 2, 3, 4. Right? So it's located on the second carbon. We always use the lesser number to find it out. So our name is going to be 2-butene. Think of the number as your address, right? You need to have an address to give you the exact location. That is what the number gives. The name is the street, but the number is the house number. All right. Once again, same thing like we did before. This I kind of cut it short. Same thing like we did before. You need to be able to tell me what where the triple bond is. Now we're dealing with alkynes. Sorry, we're dealing with alkynes. So that means you still need to tell me how much we have. So let's do this one. So I have 1, 2, 3, 4 carbons. So I still have 4 carbons. So I'm still dealing with bute. Good job. But now, because we have a triple bond, my ending is Y and S, bukyne. And then, where is that triple bond? If I start numbering, I'm going to start numbering over here. 1, 2, 3, 4. It is on the first carbon. So it's going to be 1-butyne. All right. Now, why is it 1? Because it's attached to the first carbon. I start counting from the side that's closest to the carbon. If it's in the middle, like over here, either direction does not matter, right? So this is how we are naming our alkanes, alkynes, and alkenes. I'll see you in a moment when we talk about the branch parts.